Today we're going to cover 1020A, which deals with compressors. Compressor, as you know, the compressor is the heart of the system. Without the compressor, the refrigerant does not move, nothing happens. So we want to make sure that the compressor is protected as best as we possibly can. We want to make sure that things such as the charge is right, that it's getting the proper cooling, that the electricity going to it's correct, the whole 9 yards. The compressor mess up, the whole system's down. Okay, let's talk a little bit about the compressor itself and what you're going to find out there. Number one, there's two different operating principles, basic operating principles that compressors do or have. Positive displacement and non-positive displacement. Well, they're both pumps. Doesn't matter. They're still pumps. Anytime I say anything about difference in compressors, just remember this. It's a vapor pump. No matter what else, it's still pumping. It's just what different ways of doing it. In fact, the physical enclosures, you're going to see open, hermetic, and semi-hermetic. Y'all know what the word hermetic means?
Whether if it's sealed or not.
Sealed. Okay? If something's hermetically sealed, that means it's airtight. Okay? It doesn't have any seams or it doesn't have anything that can be taken apart. Okay, a hermetic compressor is in a shell. Now, this is one of many different shells that you will see, but that is a hermetic compressor. We also have another one right there. They really don't look that much alike, but you can see that both are enclosed in a shell. Okay? Now, that's the body. That's the body type. A semi-hermetic will be bolted together. This is a semi-hermetic. As you see, these things are not like. There's a semi-hermetic. It's been taken apart. This is also semi-hermetic. We're going to talk about the differences in them in just a little while. But what about an open compressor? Can y'all think of where there may be an open compressor? Open compressors, the motor and the pump are separate. They have a shaft coming through the body somewhere or another. Have you seen one of those lately?
No.
Kind of obsolete, aren't they?
Not really. They are in our industry, but if you drive a car with air conditioning, you got an open compressor on there. Isn't it belt drive? It's got a shaft coming through to the belt that, or the pulley that operates it. Well, there you go. That's an open compressor. You still see some around, like Ricky said, they're obsolete more or less in our industry. Although, don't rule them out. I was over at a theater. Y'all ever heard of Fort Payne, Alabama?
Alabama.
Alabama. That's the home of the group Alabama. I was over at the theater over there, and they were putting on a concert, and man, that little old theater was burning up. And I stuck my nose in a little bit because I'm one of the spectators, and I was sweating too, if y'all know what I mean. So I stuck my nose in a little bit and said, hey, got air conditioning problems, that's what I do. Can I take a look and help out a little bit? And they said, come on. I go up there and I find a open type compressor for that little theater. And we got them going a little bit better, but wasn't a whole lot to do that I could do, because you can imagine how many people was in that little bitty theater with that particular group. But just the same, it opened my eyes right quick. I go, oh man, look at this. How old is this thing? Yeah. But you will see them out there. Okay. Well, let's talk a little bit about the shells that we just looked at. First of all, how would this compressor get its cooling? You don't see any fins. You see the body.
You have the refrigerant cooler.
Yeah, the returning gas. If the returning gas is not the right temperature, this compressor is going to run hot. It gets a little bit of cooling from the shell, very, very little. Now, you can see the fins here. Okay, this one, I know you can't see it from where you're at, but this one actually returns the gas not over the motor windings. It does internally a little bit, but it goes almost directly into the cylinder. But notice the fins here. That's partly air cooled, you may say. Do you see anything over here? Any fins? No. The actual suction line comes in on the back side and carries that gas across the motor windings. So it's very dependent upon the returning gas to be correct in order to be able to get it cooled correctly. Okay, we break our compressors up into some other categories too. You're going to see high, medium, low, and ultra low type of saturation temperatures that the compressors have to deal with. Now, be concerned about it, but not overly concerned about that particular problems. The reason being, if you get out here and you start having to replace compressors, occasionally you may come into a situation where a compressor has been replaced incorrectly and you're going behind somebody else. And if they don't put the right compressor back, you're probably thinking, why in the world would somebody do that? Hey, it happens. It happens. But if you're going back over somebody else's work, do a little homework and make sure that it's correct, okay? All right. Let's talk a little bit about the different styles of pumps. Probably the most common, or easiest to understand, I should say, because it's not the most common anymore, is a reciprocating compressor. A reciprocating compressor would actually have a piston in it that, I don't know if you can see this from there, but believe you me, there's pistons in here that would move up and down, much like an automobile engine. Okay, there's a crankshaft, a motor, and as these pistons move up and down, it takes the returning refrigerant and compresses it and moves it to the high side. This is a valve plate. Okay, I'm going to pass this around. This is the discharge valve. You can see what opens them is the actual pressure difference as the compressor pumps the refrigerant. The suction pressure is what pushes the refrigerant into the cylinder. Now these are called reed valves. Okay, they're spring steel is what they are. But I'll pass the plate around. You can take a look at the keepers on the back of that discharge valves there. That's to keep it in case you have a slurge or a surge of liquid or a little bit of oil come through there. It gives it a chance to react without breaking it every time. All right. Another type that's become very common nowadays is a scroll. Now, a scroll does not actually, the piston does not turn. It orbits, like so. Okay? If you'll notice on the top of that crankshaft, there's an eccentric part right there on the very top. It runs up inside of a bearing down in there and moves the scroll in an orbiting type direction. I'm looking for that other scroll that we had, and I don't see it, one that we could actually take apart. This is rather heavy, but you can take a look at it and feel it moving on the inside there. Hopefully we'll be able to show you a little more about that in just a little bit. Another type that is not as common, but you will run into it in the industrial and commercial end, centrifugal. This is the impeller from a centrifugal compressor. Keep in mind, this is a non-positive displacement. The others that we just talked about are positive displacement, meaning that everything that goes into a cylinder comes out. This one spins the refrigerant. Okay, this particular impeller would have been running somewhere around 20 to 30,000 RPM. Okay, usually see the centrifugals in the higher capacity systems and all. Now, I have a much larger centrifugal impeller. I don't know if y'all can see this or not. Can y'all see that up underneath? Okay. Can you see that impeller? Let's see if I can grab it.
David, here's that scroll.
Okay.
Looks like a scroll, doesn't it?
Yeah, let's pass that around. I'm gonna. All right. What happens here is it captures some refrigerant in here. Okay. What happens is this thing does this number right here. It captures that refrigerant and pulls it to the center and comes out. Okay, what acts as a seal here is the actual oil of the system between the two plates there. Okay. I'm going to jump back on the centrifugal here for just a minute. That the two impellers is, we're not going to pass this one around. But the one that's going around, I had a particular system. That's a high-speed centrifugal. When people say centrifugal, a lot of times they think of a low-pressure system. Well, this would have been a difference. This is a low-pressure system. That one's not. I had to replace that impeller, not that particular one, but that impeller and a shaft. Let me tell you, this is some expensive work. That impeller right there is about $20,000. Okay. That impeller that's going around, the impeller itself, and this was 15, 20 years ago, was about $5,000. The shaft and the gear that hooked up to it, I think it was a total of about $12,000. Now, you can see, you're not going to see that in a household, not like that, okay? That's the reason that that technology is for the bigger, more expensive systems. But you got to think about it. That was probably a 200-ton unit. Okay, when you look at that kind of money over 200 tons and the durability that they have, then it's, you know, it's the cost of doing business. I don't know any other way to put it. It's just the cost of doing business. Let me back up a little bit to the scroll technology. The scroll earned a reputation of, and don't get me wrong, it is very durable. But it earned a reputation when it first come out that the charge on the system was not that important. You couldn't overcharge the scroll. That's what got advertised in a roundabout way. Y'all know how something sounds great, but it's not true? Not true at all. People started replacing compressors because of electrical failures. And everybody would say, well, you know, you can't overcharge that scroll compressor. Something else must have been going wrong. Well, that's not the case at all. The scroll compressor itself will pass liquid through it, usually with no damage whatsoever, because it more or less releases and unloads. That's just part of the way it's built. Here's the problem. The bearings in the system still need to be lubricated properly. If I pull this rotor out of this compressor and I look down here in the bottom, I will see a little device that picks up the oil and sends the oil up through the shaft